Okay, let's have a look at the next one then. Let's have a look at the next one. So, similar kind of setup. We've got a quadratic with some unknown. We've got k in there. And we have no real roots. So if it has no real roots, what are we looking for? What's the condition?
Less than 0.
Careful. Good, well done. So write that down. By the way, if I see that written down, I'm like, I know what you're talking about, so I'll probably give you a mark for it. Yeah? Because you said, I have to identify the discriminant has to be smaller than 0.
So you can give us like separate marks for
Absolutely, absolutely. Yeah. The final mark is like just one of the many marks that I can give. Yeah, so the final answer. So I want to see that working. Okay. All right, good. So what's b squared?
0.
B squared?
16k squared.
It's 16k squared, right? Minus 4 times 2 times 2. So what's minus 4 times 2 times 2?
-16.
Good, well done. Is that okay? Good. All right, okay. Now are you happy that here I could divide through by 16? Get rid of that 16 there. So I can say k squared minus 1 has got to be less than 0. Okay, just tidy it up, make it a little bit simpler. You don't have to, but I would. All right. All right, okay. Now, what question am I asking here? So this is still a quadratic, k squared minus 1. What question am I asking? Am I looking for a region above the axis, below the axis, or under the axis? Well, same thing, or on the axis. So if it's less than 0.
Below.
Good, exactly. So I'm looking for a region below the axis. I'll come back to that. So if I'm looking for a region below the axis, what do I have to find first?
The roots?
Yeah, exactly. I need to find the roots. So let's do that. Okay, so if I find the roots, are you happy I just set this equal to 0? So I go k squared minus 1 has got to be equal to 0. If I'm going to solve this, what do I get?
1. Positive or minus 1.
Good, exactly. So I get k equals plus or minus square root of 1. So k has to be equal to positive 1 or negative 1. Is that okay? Yeah? So when I come to draw this, are you happy it's going to be a positive, happy face quadratic first? K squared minus 1 is positive. Yeah. So okay, we go like that. So what's this point over here going to be?
-1.
And what's this point over here going to be? 1. Okay, now come back to this. I want to find a region below the axis. Below the axis.
So we take only the region below the axis.
Absolutely.
It has to be
Like it's the opposite of the one above.
Are you happy that every single point between -1 and 1 will correspond to a region below that axis? Yeah? So how am I going to write that as an inequality, I wonder? How can I say I want all the points between -1 and 1? Good. Are you happy with that? Because what I'm saying here is that k has to be bigger than -1. That's satisfied, so everything to the right of -1. However, I can't have everything to the right of -1. It's also got to be smaller than 1 as well. So it's got to be bigger than -1, which counts as everything to the right, and it's also got to be smaller than 1 as well. And the only region that satisfies that is between -1 and 1. Is that okay? Yeah? And there's your answer. Now you notice here, how many inequalities have I written down there? It's one inequality, right? It's one inequality. How many inequalities did I write up here?
2.
2. Now have a look at the graph. How many regions did I shade in here?
1.
1, and I had 1 inequality. How many regions did I shade in up here?
2.
And I had 2 inequalities. So in general, the number of inequalities that you need corresponds to the number of regions that you're shading. So if you're shading in 2 regions, you need 2 separate inequalities. If you have 1 region, you just need 1 inequality. Is that okay? Okay, good, good. Let's move on to this one then, so number 3. So we have, if you can't read it, we have y equals kx squared plus 4k plus 1 times x plus 3k plus 1, and we're told it has a repeated root. Now if it has a repeated root, how many roots are we looking for?
More than 1. 2. More than 0.
I would say it has 1. If it has a repeated root, it means it's the same.
How
If you repeat something, it means it's the same. That's another way of saying it has equal roots. So we're looking for one distinct root, which means that the discriminant has to be equal 0. Has to be equal to 0. Now be careful when you stick this in here, right? Because there's a little bit more work involved. What's b in this case?
16k. Oh, wait.
Is the whole of 4k plus 1. Do you see that?
Yeah.
Because that's the whole thing which is being multiplied by x.
So we'll just do it slowly.
Yeah, so I just write that all in one bracket.
16k. Oh, okay.
I'd write it like that. Okay? Don't jump ahead steps, like write down every single step. Right? Okay, then I take minus 4. What's a?
K.
Yeah, so it's just the number in front of the x squared, which is k. What's c?
K plus 1.
Good. Now would I write it like this?
No, we need brackets.
Good. I want the whole of 3k plus 1 being multiplied by 4k. Is that right? Yeah? Okay, and that's got to be equal to 0. Does that make sense? Yeah? Okay, now I can go through and start expanding things out and simplifying. So if I expand this out, what do I get?
16k squared plus 1 plus 8k.
Good. Okay, if I expand this out, what do I get?
Negative 12k squared plus negative 4k.
Yeah, does that make sense to everyone? Sorry, what did you say?
Negative 4k.
Does that make sense to everyone? Yeah, because you're taking the whole of negative 4k and multiplying it across these brackets. So negative 4k times 3k makes negative 12k squared, and negative 4k times positive 1 makes negative 4k. Good? Right. Now let's tidy this up. So I'd see a couple of k squareds in there. What's 16k squared take away 12k squared? 4k squared, yeah, good. Okay, what's 8k take away 4k? Well done. And are you happy? We just have a plus 1 there. Okay, now that's just an ordinary quadratic. That's just an ordinary quadratic. Could you go ahead and solve that for me?
Yeah. 2k plus 1
Okay.
square.
Yeah, perfect. You happy with that? Yeah. So if you sit down and think about it, you're saying two numbers which multiply together to make 1. Sorry, no. Let's do it the way which we did before. Right. So you're dead right if you can jump straight to there. But just for practice, because we only looked at this last lesson, let's see if we can factorize this. So you're looking for two numbers which multiply together to make 4. Remember, it's 4 times 1 now. And add together to make 4. So what works? 2 and 2, right?
Yeah.
Okay, and then that's what we break the 4k into. So it'll be 2k and 2k. And everything else stays the same. Okay, you then break it down the middle, and you just factorize each side separately. So here we can factorize out 2k, and therefore you get 2k plus 1 times by 2k plus 1, which you can absolutely write as, I'll write it over here, 2k plus 1 all squared equals 0. Which means what's k got to be equal to?
What?
What's k got to be equal to? Negative 1 over 2. Negative 1/2. Do you see that? Are there any questions about that? Megan, Batakan, any questions about that? Okay, I'll set you off on the last one then, so I'll give you a chance to have a look at this yourself. Notice the question. It has real roots. It has real roots, right? So what condition am I looking for here?
It means it can have like just one single
Yep.
solution, but can be like two solutions separate.
Yeah. So basically, real roots, if you think about this over here, real roots means either one root or two roots. You can't have no roots. So it's got to have at least one. So therefore, what's the condition on the discriminant?
Bigger than or equal to.
Perfect. So it's either got to be bigger than or equal to 0. Okay. Can I give you a couple of minutes to have a look at that for me?